So kita proceed next.
Sekejap Aisyah.
Alright, signal and propagation lah. Alright.
Okay, Assalamualaikum and a very good morning. My name is Raiza, and today me and my team will present more about signal and propagation. So my teams are Akmal bin Muhammad Ruslan, Farhan Shah bin Ahmad, Nadira bin Rosdi, and me myself, Surya Aniza bin Masaidi. So signal is actually an electrical or electromagnetic current that is used for carrying data from one device or network to another, while propagation is the time required for a signal or wave to travel from one point of a transmission medium to another. So then we are talking about wireless signal propagation. Wireless signal propagation is the movement of this radio wave are functions to pump out the wireless communication signals to devices in the field via electromagnetic waves. By receiving these signals from the various sites, it creates a two-way communication since the devices transmit similar types of signals back to sites. Okay, and then we will talk about the signal propagation range. So there is three types of range, which is transmission range, where the communication possible in both direction and it has relatively low error rate. And then next, the detection range. The detection of the signal are possible, and then the communication can be may be possible because of error rate are too high. And the lastly would be the interference range, where signal may not be detected, and it can add more background noises and also interfere to other transmissions. Next, I will pass to Nadira.
Morning and Assalamualaikum. And now I will continue a little bit about signal propagation. Okay, first, propagation in free space always like light, which is in a straight line. Artinya kalau tak ada any obstacles, dia punya signal tu straight line je. Then radio signal are just like there are different wavelengths along the electromagnetic spectrum. Next, the receiving power deadlines proportional to 1 over distance between sender and receiver square in vacuum. So, in general, there are certain ways that various objects can interfere with transmission. First is fading due to the atmosphere and large distance. Next is shadowing. Here could be wireless shadow where if we have a transmitting Wi-Fi signal or ZB signal and it will hit a wall and there will be a shadow behind it. The third one is reflection at large obstacles. Reflection ni macam cermin, just like a mirror. And then there can also be refraction depending on the density of a medium. You know that if you have a beam of light and then enter a media that's more dense like water and light can bend. It can go into the water tapi dia mungkin bengkok sikit dia punya signal tu. That's why kalau kita duduk dekat dalam swimming pool, kita tengok kita punya kaki jadi pendek. Itu disebabkan light coming out tapi dia sedikit bengkok before masuk kat kita punya mata. Sama juga dengan wireless signal. Wireless signal ni sometimes dia akan hit the object macam glass and or dry wall and then we through it but there may be bend a little bit masa dia masuk dekat object tu. So wireless signal can refract. Next is scattering at small obstacles. Contohnya kalau kita duduk dekat depan cermin, then ada light. Kita boleh tengok balik kita punya muka dekat dalam cermin tu. Dia dah scatter. Lepas tu sebabnya mirror ni are really good at reflecting things. But if kita ada dinding tu cover dengan white paint, itu akan jadi lain. Dia akan jadi scattering. Light from image might hit the wall and it will be scattered all over the place. That's why kita boleh nampak dinding tu warna putih je. Tak dapat muka kita kat dinding tu. Same thing happen dengan radio frequency. Radio frequency hit certain objects that are designed to reflect very well. Last but not least is there's also another effect that can happen which is called diffraction at edge. This one might be a little bit non-intuitive because we doesn't see it so much with light. Sebab light ni has high frequency and turn it out high frequency doesn't really differ much. But kalau radio wave, dia have lower frequency. Macam kalau kita duduk kat bukit, lepas tu duduk dalam kereta tapi dekat area bukit, kita still je dapat dengar radio dekat dalam kereta kita tu. Sebabnya amplitude modulation radio ni dia mempunyai low frequency dan dia boleh bend around the tree, laluan-laluan kita lalu tu masuk dalam kereta. That's why boleh dengar radio dekat dalam kereta. Okay, next slide. Okay, next is multiple propagation. Signals can take many different paths between sender and receiver, arriving at different times with different signal strength at the receiver. Okay, sini nak bagi tahu yang signal tu ia bergantung dengan berapa jauh sender dengan receiver ambil masa untuk sampai. Berapa jauh signal tu ambil masa daripada daripada sender nak pergi ke receiver. Dia lalu-lalu dekat obstacles tu apa semua. Dia ada masa sendiri. And then runtime dispersion, signal is dispersed over time. First signal is divided into weaker path. Second, interference with neighbor symbol which is ISI. And then reduction of effective bandwidth. Ianya dia akan effect bandwidth kalau makin jauh signal dengan daripada sender tu dengan receiver. That's all for me. Thank you.
Now I will discuss about propagation modes. The first propagation mode is ground wave propagations. It uses frequency below 2 MHz and it also slow down wavefront due to electromagnetic current induced to the earth. Ground wave propagation also suffer from diffractions and scattering from the atmosphere. The example of ground wave propagation is used on AM radio and FM radio. And next is skywave propagations. This wave use frequency between 2 and 30 MHz. Its transmit signal is reflected from ionospheres and reflected by the Earth. Skywave propagation bouncings allow signal to be picked up by thousands of kilometers from the transmitters. The example of skywave propagation are used on amateur radio, TV radio, and international broadcast, BBC, and Voice of America.
Okay. Hello, test. Dengar ke?
Clear. Dengar, clear. Alright.
Okay, now I will be presenting about the line of sight propagation. Okay, in line of sight propagation, one of the condition for it, the antenna satellite must be in line of sight above 30 megahertz. Ground wave and skywave do not operate at all. There is no reflection from ionosphere, which allow satellite communication not beyond the horizon and back. For ground-based communication, the antenna need to be in line of sight with each other. Next. Okay, now I'll present about the line of sight transmission impairment. Transmission impairment is it means that the signal that are transmitted at the beginning of the medium are not the same as the signal that are received at the end of the medium. So this impairment tend to deteriorate the quality of the analog and digital signal. Source of impairment, firstly is attenuation. Attenuation means that the strength of signal fall off with distance over transmission medium. Attenuation factor for unguided media is the signal received must have sufficient strength so that the circuitry in the receiver can interpret the signal. The greater the attenuation means the higher the frequency for distortion. As in noise, noise is an unwanted disturbance in an electrical signal. Noise is an error or undesired random disturbance of a useful information signal. Okay, as for atmospheric absorption, atmospheric absorption usually consists from water vapor and oxygen. So these two elements is what contribute the most to atmospheric absorption. In water vapor, the peak attenuation is near 22 gigahertz and low attenuation is below 15 gigahertz. For oxygen, absorption peak near 60 gigahertz and lower below 30 gigahertz. So meaning lower frequency band usage helps to reduce atmospheric absorption. Okay, next is multipath. Multipath is the same as what Nadira speak just now about the multipath propagation. So meaning signal can be taken to many different paths between sender and receiver due to reflection, scattering, and diffraction. And lastly is the refraction. Refraction occurs when the signal is being bent. Typically happen when a signal passes through a different medium from what it came from. So example, from air into the water, thus causing the direction of the wave to change. Okay, that's all from me and my group. Thank you.
Thank you, sir.
So thank you. Alright, thank you. And good job, dua-dua group.